Welcome.
Laughing or something?
You were. Hello. We're going to do some math today. I don't think anyone's watching yet, but you know what? We're live. Whoa. Holy Glaven. We done it. All right. We'll just wait for some people to show up. How do I even share the stream? YouTube is odd. I know Allie's going to be so happy with me doing the live stream. Yo, what's up? Okay, wow, everyone's showing up. How's it going? Wow. All right. Friggity frick frack. I don't know how I could trust anyone, but I want someone to link me to the URL you're on. I would like to share this live stream on my Twitter, but I can't seem to do it. Can you do that for me? I want to tweet out this live stream. We're going to be doing 2 plus 2. Okay, the answer's 4. Done. Sorted. Today I'm going to be helping you with your math homework. What? Is that true? Yeah, it's true. I'm actually going to have to turn on slow mode because the chat is going so fast. Right. No, I'm not going to turn on slow mode. What I'm going to do is source your comments from here. Do you see the link yet, by the way? Trying to figure this out. Hard times. Yo, you guys are commenting so fast. We're going to be doing some algebra, some calculus, some geometry maybe, some trigonometry. We got some Alg 2, linear algebra. Who knows? You found the link yet?
Yeah.
Thanks.
I got the link.
Okay, Facebook, it's me, so I can... if you want some help with math, everyone, which I'm going to be doing right now for you, hopefully. If you're not here for math, hope you enjoy whatever you're watching right now. There's 1,000 of you. There's 1,000 of you watching right now. Wow. But if you are here for math homework, I would like you to tweet me using the hashtag Evan help my math. Why? Because I'm an idiot. So Evan, you know what? Evan help my math. Hashtag Evan help my math. That's it. Tweet me your math questions with hashtag Evan help my math, and I'll help you solve them live on YouTube. What? Is that what he's doing? Can you believe it? Can you believe this guy doing a live stream? There we go. What a weird link they've given me. And swoosh. Here we go. Now, if you've started tweeting with that fun hashtag, I can help you solve your math. Good. We have math written on the board because that's what we're going to be doing. The first person that tweets me, they win the goal here. Where's Maurice? Hope you're all having a good Monday. You just came back from the weekends. Monday gets a bad rap. I think Tuesday's much worse. Tuesday's like enough into it where you're like, but there's too much. It's like 4 days until Friday. It's much worse to me. Do not say maths, please. It's obviously math, just one math, no S. Unless you're doing mathematics. We just lost a poster. Goodbye, Logan. Logan Paul. We have a Logan Paul poster. We really love his stuff in this flat. Here we go. Okay, we've got some tweets. Someone just said surds, please. Is that a Western? Is that like a... Isn't that like what the Turkish army is called or something? That's absurd. I don't know what surds are. I'm really sorry. Is that some newfound... I've got 2 degrees in math. I don't know what the word surds is. Derivatives, please. Yes, I can help you with derivatives. Isaac.
Teach me about imaginary numbers.
Teach you about imaginary numbers. If you get... Everyone's saying reducing surds. Give me a problem. I will solve the problem. Right now, I'm just getting things like cosine rule. Give me an exercise that you'd like help with using cosine or surds. Whatever these surds are. I probably know what they are. Evan, I met Patty the other day. That's pretty cool. Evan, you're awesome. Thank you. Thank you very much. Please explain normal distribution. I can do that once you give me a problem. Hey, there we go. I have been tweeted. Okay, this is from Alyssa Luz. Alyssa Luz. This is pretty basic. I hate the word basic in this. This is a pretty standard problem when it comes to geometry. We're going to quickly do this and move on to surds, which everyone really wants to know about. It says the lengths of 2 sides of a triangle are 4 and 7. Give all possible lengths as integers for the third side of the triangle. Why does it say... Oh, I think Okay, this person's doing what's it called? Process of elimination. Just lost my cap. So it says that you have a triangle, and one of the sides has a length of 4, and one has 7. So I mean, this is a Pythagorean theorem thing. It's just a squared plus b squared equals c squared. So it's going to be 16 plus 49 equals the square root of your answer, because 16 is 4 squared, 7 squared is 49. What is... Is it 65? Yeah. What's the square root of x? Oh, Lord. Whoa, once an integer? The lengths of the two sides of a triangle are 4 and 7. Oh, we don't know if it's a right triangle. Oh. Oh, no. So it's not necessarily going to be Pythagorean. The lengths of two sides of a triangle are 4 and 7. Give all possible lengths as integers for the third side of the triangle. So if it's not going to be necessarily right, if it's literally just going to be 4, 7x, then I don't have the tools equipped for this, because geometry is something I did in 9th grade and is never used ever again. Sorry. I'm not going to be able to do that, and I'm not going to pretend I am. The possible answers left she has are 5, 6, 7, 8. I mean, I'm pretty sure this, you could, if it was right, 4, 7, it's got to be bigger than both of them. It's got to be smaller than. No, I'm sorry. I'm not going to do this one. Thanks for the effort. You're the first person that's tweeting your problem. You had to go with geometry. But we're not going to be doing any geometry, most likely. It's most likely going to be algebra, calculus, other things. Let's see. Surds. Okay. I'm going to have to find a surds problem, because it seems like that's the only thing people... Either way, maybe they're just saying another word. All I'm seeing is the word surd. So I'm going to have to look up a surds problem. I'm gonna Google, what are surds? I don't know if this is a British word for something. In America we call something else. A surd number. I like how if you Google surds, it just says, a surd is a surd number. Thanks, Google. That's really great. That really helped me. Connie, do you know what a surd is?
No,
S-U-R-D.
S-U-R-D. Inform me.
I don't know. I've never heard the word in my life besides my group chat.
Somebody I follow has messaged you a maths problem. Do you want to try that one?
I will right after I find out what a surd is. A surd is a square root which cannot be reduced to a whole number. Oh. Since when? Since when is that the word for it? That's just... What? I've never heard it referred to as a surd. Is that a new word?
That might be the new GCSE thing.
Alright. I mean, I know that's a math problem that I've done in, like, school, but we never refer to them as surds. For example, square root of 4 is 2. Not a surd, because it's an absurd. No, it's because it's an integer. The answer is a whole number. However, the square root of 5 is not a whole number, so it would be a surd. You'd have to use a calculator to find that the square root of 5 is 2.23, blah, blah, blah. Instead of this, we often leave our answers in the square root form. Oh! Oh my god! Okay. So a surd is basically when you're taking the square root of, let's just say, I'm trying to think of a good example. The square root of 63 is 9... well, the square root of 63, you can take a 9 out and a 7, so it's going to be 3 squared root 7, and that's a surd. Cool! I'm glad we're on the same page here, and I know what a surd is now. Let's see. You need to be able to simplify expressions involving surds. Here are some general help. Yes, of course, that does make sense. Would anyone like some surd problems? Because I'm going to give you some really quickly. This is
Surds are radicals in the US.
Radicals!
That was from House Slytherin.
There we go!
Twitter.
Surds! Alright, we're going to do some radical surds. Doubling up. Do you know the t-shirt that has like the I talking to the pie, and the I says, get real, because I is imaginary,
Okay,
and then the pie says, be rational, because he's irrational. Math shirts, everyone. So we're actually going to get into some surds now. So all those people that were like crying for some surd help, here's your time. Right? We're gonna get you an A on the test. Just with surds. Let's just hope the exam is just surds. First of all, let me just make sure I'm in. I'm just making sure I'm in scene here. Yeah, cool. So I'm gonna write this real big. This is a very simple one. Square root of 12. How the frick do we do that? I don't know. 3 squared is 9, and 4 squared is 16. So obviously it's in between there. You can't. So it's got to be Absurd. It's got to be an irrational number. A rational number. So what are we going to do here? Well, first of all, we want to find the factors of 12. An easy way to think of this is, what are some perfect squares that are in 12? Well, 12 is made up of 1 times 12, and 2 times 6, and 3 times 4. Out of all of these, you got your buddy 4 here. He's your best friend, because we already know that he... 2 squared is 4. 2 squared is 4. That's pretty radical. Pretty radical. So what we're going to do is change the square root of 12 to the square root of 3 times the square root of 4. That's a law, right? You should have studied that law already, I'm hoping. If you're unaware, that's a law. Basically, the law is the square root of AB. I'm going to write this over here just so we know. Square root of AB equals the square root of A times the square root of B. Ta-da! Pretty good. There's one more rule you should know, which is the square root of A times the square root of A equals A. Good? Great. So if we have the square root of 12, that's just going to be square root of 3 times the square root of 4. We know this guy. He's 2. So the square root of 12 is equal to 2 square root 3. I'm sorry about my bad handwriting, but this is your answer. It's a very basic problem, Evan. Why don't you give me something that's asked you to be in the GCSEs? All right? I hate the word GCSE. It's just too many E sounds. So we're going to have to do one that's a bit more difficult. Sure. Let's keep the same things on the wall here. We're going to keep the formula that you guys should know, along with the rational surds. What if I gave you the problem, the square root of 12 over the square root of 6? Cool. It's a bit more difficult, though, now. What are we going to do? It's not. It's actually a lot easier. If you recall this formula right here, square root of A, B, you can separate them. The same goes for these guys, for division, kind of. Sometimes. Don't take my word for it, but also take my word for it. In general, this works. You can do square root of 12 over the square root of 6 is the same thing as square root of 12 over 6. Hooray! You know what 12 over 6 is. You were in 3rd grade, year 4. 12 over 6 is 2. The answer is just square root of 2. What? Shit. You did the surds. You figured it out. I think you're doing a lot better here with the surds. E equals MC squared, someone's put in the chat. Yes, that's correct. Good job. It's a bit physicsy. And we'll do one more of the basic surds. This wasn't even hopefully complicated. We're gonna get crazy complicated here. I'm gonna give you the square root of 8. Oh shit! Over the square root of 6. How are we gonna do this? I don't know, man. What we can do is a combination of the first problem I did and the second one. You know, you're looking at 8, and you already know what 8 is. You know 8 is 2 cubed, because you just love cubed numbers. That's what you do for a hobby. But also, 8 is 4 times 2. 4 is our perfect square. So, you want to take him out. Square root of 8 is now actually... That's not a square root sign, that's 2. I was already doing the math, my bad. Square root of 4 times the square root of 2 over square root of 2 times square root of 3. Because that's, 2 times 3 is 6. And 4 times 2 is 8. This actually comes out really nicely. You know the square root of 4 is 2, so we're just going to cross him out. Now it's 2. And look, there's a square root of 2 on the top and bottom. You can cross those out, because they cancel. Square root of 2 divided by square root of 2 is 1. 2 divided by 2 is 1. 8 divided by 8 is 1. Same goes to square roots, or surds. So we actually have 2 over square root of 3. So that's 2 over square root of 3. And that is the answer.
Sally's here. Sally LePage.
Sally LePage, my bae. However, you might be looking at the square root of 3 as a teacher and going, I'd like to mark them off for this. I don't like it when there's surds in the bottom. I find it absurd. I find it not rational. Well, if you're a teacher that wants to be like that, fine. You know what we're going to do instead? We're going to bring him up top. Evan, how do I do that? What am I supposed to do? Well, you can multiply any number by 1 and it stays the same. You haven't proven that yet, but you know it's true. 8 times 1 is 8. Cool. Hooray. 2 over square root of 3 times 1 is just 2 over the square root of 3. What if, instead of a 1, we replace it with something that is the same as a 1? So 2 over square root of 3 times 8 over 8 would just be, the same thing. Or we can multiply the top and bottom by this boy right here, square root of 3. Why? Because this rule right here that we've written on the board for surds, for rationals, whatever you want to call them, proves that if you multiply a rational by another rational, you get irrational by another rational. I'm just going to say surd because it's funny now. If you multiply a surd by a surd, you get the insert of it, you get the inside. So what we got to do here is multiply this by square root of 3 over square root of 3, which as you know is 1. The top is 2. Is this still? I just want to make sure this is on the screen here on my camera. So that's 2 square root of 3 over square root of 3 times square root of 3, which is equal to just 3. The answer that the teacher will love you for and probably give you like a 9 out of this new GCSE CSE scale is 2 square root of 3 over 3. Holy crap, the teacher says. I can't believe I have the smartest student in the UK in my class. That's what she said to you after you watched this live stream. Can you believe that? Good. Whew, what a good time. Now, Connie, I hope you've enjoyed the surds. If you have any more surd questions that are like quite difficult, send them my way using hashtag EvanHelpMyMath. I would add that to my live stream, but I can't seem to do that because I'm an idiot that doesn't think before. Otherwise, I would have put that in the text. Actually, can I edit the text? Let me just do that now. Hashtag EvanHelpMyMath. Heck yes, I could edit it live. What's your friend's Twitter?
Oh.
I was gonna do a live stream. If you want to take a screenshot, by the way, here we go. 3, 2, 1. I'm about to erase, and it's gone. Someone also tweeted my hashtag, and they needed some help.
I'm gonna just send the image to you.
All right, you can send me an image.
It looks like
A lot of you guys have geometry. Ooh, integrals. Hashtag EvanHelpMyMath. I don't have a math exam till next school year, but I'm having problems with solving this because I'm stupid. I don't think you're stupid.
Somebody also said something about parabolas.
Parabolas?
Parabolas.
Someone got a parabolas? I'm trying to dress up tonight.
Hyperbole.
Hyperbolas. Parabolas, that's some geometry. I didn't do geometry until I was like 13, and it's been over 10 years. Connie, you literally just copied and pasted my link.
No, I didn't.
Yes, you did. You literally just...
I'm very tired. Okay?
All right, so I'm going to do this girl whose name is Elaine Clifford, maybe spelled differently. Hello, Elaine. She has a quick question that is, she wants to find x. I don't know why. I'm going to do this one as quickly as I can. Plus, thank you, Connie, for actually giving that to me. The question is 10x minus 4 plus 4x equals 6x. How do you find x? Whenever you're doing any problem where it says, how do you find x, your number one goal is to remember numbers and letters hate each other. They're enemies. They don't want to be on the same side. Right now we have x's hanging out with numbers, right? Coefficients hanging out with not cool. Okay, we gotta what's that called? What's the word I'm thinking of? Segregate, right? It's not usually a good thing, but segregate the numbers from the letters. At that point, we have 10x and we have plus 4x. However, we have minus 4. Shh, Tommy, hush it up. Oh, he told me my audio is lagged by half a second. Thank you, Tommy. I'll have to figure out what's going on. 10x plus 4x is on the left. We want to get rid of minus 4 because, like I said, keep him on the right. So we're going to add 4 to the left and add 4 to the right. That lets you get this. However, we have another issue. Now we have a letter and a number hanging out on this side. So we actually want to move him over. Subtract 6x from both sides. Because like I said, you just want numbers on one side and letters on the other. You have 10 plus 4 minus 6. 10 minus 6 is 4. 4 plus 4 is 8. So we have 8x equals, and this is 4. All right? Like I said, you want the numbers and letters separately. This is 8 times x. How do we get rid of 8? Divide everything by 8. Whoosh. X equals 4 over 8, which you know because you're so good at mental math. It's just 1/2. It's 1/2. You did it. X is just 1/2. And you can, if you want to test it, if you have extra time, go back to test the question. Put 1/2 in. You get 5 minus 4, which is 1, plus 2, which is 3, equals 6 times x, which is 3. 3 equals 3. You did it. How does it feel? Does it feel good? Does it feel good knowing you're the smartest person in your class? I hope it does. You can do it, right? You can do the math. Now, Connie's messaged me, someone on Twitter. Who is this person? So if your name is Charlotte, Cookies Forever 121 on Twitter, thank you for tweeting me the math problem here. Oh, Lord, you want me to do geometry. Why just give me geometry? The one thing I said, I'm not going to fuck around.
Somebody said
Parabolas.
parabolas aren't even geometry, they're algebra.
Oh, yeah, parabolas. Well, this true. I never said that wasn't true. But this person is saying an acute angle A. The acute angle A is such that the tangent is 2. This looks more like trigonometry. I'm going to be very honest. If I have the ability to do this without a nice notebook out. So someone said there's an acute angle. We're going to give it little blushing lines because it's very cute. And it is such that the tangent of A is equal to 2. Draw that right there. So what we know with that, you know the tangent. I don't know what you learned in the UK, but I learned SOHCAHTOA. SOHCAHTOA. If you don't know what SOHCAHTOA is, write it down. Toa. So I know Toa. Gosh dang, SOHCAHTOA. Why do I have it like this? That's not how you spell SOHCAHTOA. Obviously, don't write it down if you can't spell SOHCAHTOA. Who doesn't? Who cares? We know Toa, right? I told you about it. Tangent, which is the T, is outside over adjacent. Yeah. So, fuck, that's not true at all. Do I not remember what SOHCAHTOA stands for? I don't. I don't need to know. Because
Cosine tan.
Really? If you know what SOHCAHTOA is, that's great. If you memorized what tangent is, that's better. Tangent is equal to the sine... tangent x is equal to the sine x over the cosine of x. That's pretty simple. However, what if we made it easier? Tangent x is also just equal to the outside over, well, the far. I know this has something to do with the SOHCAHTOA. The far over the close. I believe it's outside over adjacent. Maybe that's where the OA comes from, outside over adjacent. So if this is a... SOHCAHTOA, first of all, I'm not doing geometry. We're just going to stop there.
Whoa.
Fuck geometry. I'm not attempting it.
it.
I have like books in my room where I could reference
What is
this.
a tessellation?
Tessellation is something you shouldn't be talking about with your family. We're not doing geometry. If you give me geometry, I'm not going to read it. I'm just going to cut the ball there. If you have issues with geometry, Google it. Use Khan Academy. Evan's not helping you with that.
Someone said, can you come up with another cool maths riddle like the one you said?
I cannot come up with another cool math rule. This has been very unsuccessful for people with geometry. Sorry. It's SOHCAHTOA. Some old hippie caught another hippie tripping on acid. What? That's a weird acronym that I didn't expect to read on a math stream. Can you do... I'm just trying to... It's SOHCAHTOA. Oh, it's SOHCAHTOA.
Yeah.
Thank you. I forgot the H.
Yeah.
My bad. I don't need to know what the letters stand for. This isn't... I mean, you do. Everyone's tweeting out, this isn't geometry. Well, thank you. Can you explain system of equations? Sure. A system of inequalities.
Evan.
That's me.
So.
No, I can't
equals
sketch for
opposite
you.
Over hypotenuse. Cos equals adjacent over hypotenuse. And tan equals opposite over adjacent.
It is opposite over adjacent.
Yeah.
Good. Good news, that was something that for some reason I remember but didn't know how to implement. Literally, my mentions are just full of graphs and geometry. I don't have any graph paper here, folks. I'm not graphing a hyperbolic statement. Here we go. Nope, there we go. It's more geometry. I feel like the only thing people have issues with is geometry, which is quite unfortunate.
Geometry is evil!
Yeah. That was the first course I had to take when I went to high school, though, and then I never had to use it ever again. So it's kind of like, I'm sorry. The other maths the other maths are like building blocks. You take algebra, algebra 2, trigonometry, calculus, calculus 2, calculus 3, ordinary differential. You have to use all those for each other. Geometry, kind of, but not quite. I never had to care about angles. Let's see. A-levels are hard. Help my math. Yet again, someone wants me to sketch. I'm just trying to get one fucking problem. Okay. Give me one problem here. There's another geometry. Fine. I have one, everyone. Thank you to Megan. Megan Noya. Thanks for sticking with me. We're going to do a systems of equations problem, which can also be seen as linear algebra if you want to do it a fun way, which we're not doing because I'm not complicating things for you. 3x minus 2y equals 5 halves. Obviously, you need more information. There's two unknowns, and there's not enough information. So we also have 1/3 x plus 3y equals -4/3. Now, one thing I need to ask, if Megan has tweeted me this, she typed in 1/3x, which looks like this. The only issue I have with that is it this? Is it 1/3 of x, or is it 1/3x? Very different. I'm going to have to assume it's this, even though she should have PEMDASed it, or what do you guys say here, BOMDAS, or something in the UK. So if this is your system of equations, you want to find out what's x and what's y. All right. Most of the time, if you have to do one of these problems, it's a word problem, and they're going to be like, John has a fence. He's trying to build a wall to keep out the sheep. How do we build the wall with this amount of stuff? And here's some... Basically, this is what it's come down to. Easiest thing to do for me, you can use substitution method. I personally prefer the elimination because it's fun. It's like you're solving a little puzzle here. What you want to do is get one of these. Let's just start with x because I think that's going to be easier. Yeah, you want x to disappear. Get rid of it. All right. At this point, if we added up this equation to this equation, you get 3 1/3 x. Not good. However, if you divide this whole equation here, let's just put it here. If you multiply this by -1/9, for some dumb reason, I feel no. I'm just gonna have to go with it. This is actually the more difficult version. The easier way would have been to go with the y, which would have been 2/3 or 3 halves. Multiply this entire equation by 1/9. Why? What the frick? Because if you do that, 3x over 9 over -9 is going to be -1/3. So the top becomes -1/3 x minus, plus, because we have negative there, 2y over 9 equals -5/18. So now with this, if we add that to our second column, we're just going to add these up. These right here, they cancel out, and you're left with 3y plus 2y over 9 equals -4/3 minus 5/18. And as you remember from the last problem, that's great news! The y's are on the one side and the numbers on the other. There are some numbers over here though, so we kind of want to bring them back. So let's just do the math here. In order to do this is annoying doing fraction math, but multiply the top and bottom of this by 6 so that you have the same denominator in the bottom. That's going to give you -24/18 minus 5/18. If you're subtracting negative numbers, it may get confusing. My 8th grade algebra teacher, he taught me to do a zap zap. Zap zap is changing all the negatives twice. Is when you see a negative, if you see minus, you go zap zap. You just change it from a plus and a negative. So instead of saying 5 minus 5, you say 5 plus -5. That helps your brain process what you're doing when you're adding and subtracting negatives. Just as a little tip. If you want to zap zap, it'll help you out. Zap zap your grade up. So -4/3 plus -5. Yep. I just zap zap that one. There we go. -24/18 plus -5/18. Now we know these two negatives are being added, so it's going to be a bigger number than either of them. And that comes out to -29/18. Right? Is that good? We're all hunky-dory here. I know it's getting small. It's getting a bit small. I'm going to write bigger. I apologize for that. So now we have -29/18. Writing bigger, I'm sorry. 3y plus 2y over 9. We need to get this 9 out of here. No one likes a 9 dangling down there. So multiply the entire equation by 9, and you're going to get 27y plus 2y equals, oh, here we go, 9 times 8, 9 on the top with 18 on the bottom. You should know if you multiply this by 9, these cancel out and you're left with a 2 on the bottom. Fraction. We're not doing fractions, we're doing system of equations. Otherwise, I'd go more into that. So that leaves you with negative 29 over 2. At this point, you can see you have 29y equals negative 29 over 2. If you divide both sides by 29, you get, and hopefully we're still on the screen here. Go all this other way. Remove Bender's hand. Y equals negative 1/2. You did it. Hello, Ellen.
No.
I mean, Luke.
What up, Vanilla Face?
We're doing a math live stream.
Oh, don't you go away?
Yes.
Alright.
I love you.
Jeez.
I'm bluntly honest. So it's negative 1/2. In terms of x, you can plug negative 1/2 into the first equation here for y and get the answer. So negative 1/2 into here would be negative 2 times negative 1/2, which is positive 1. So that's just y. I mean, that's just 1. Fun enough. That's positive 1. Bring that over the other side. 3x equals 3/2. I know I'm doing this very fast. I want to go over the next problem. I'm sorry. And x equals, divide both sides by 3, 1/2. So hypothetically, it's 1/2 and negative 1/2. So just to test that, 3/2 minus negative 1/2 is 5/2. Is that correct? No, because this would have to be. Oh, it is. It's 3/2 minus negative 1, which is a positive 1. Good. We solved it. The answer to that, if you're taking pictures, it is going to be 1/2 and negative 1/2. All right. Hopefully that's good. Hopefully you're all with me. Hopefully, I'm going to slow down the chat for a bit. Have you heard of Hannah Sweets? Someone tweet me the Hannah Sweets problem. I will do a probability problem next if you need any probability. Thank you very much for tuning in. I hope this is helping you in some way, at least understand some of the basics of it. The chat's going very fast. Let's see. People, I don't know if people are just jokingly tweeting me geometry now, and I'm like, I'm not doing geometry. Let's see. Do. Bop. All right. Someone is giving me a geometry problem. Let's see. Ooh, a geometry problem. I don't know what you guys are just a bunch of pranksters here. Let's see. Oh, we have more surds. Since everyone loves surds, I do want to do a probability problem. It's just this is the first one that's not geometry that I've seen now. Maybe I need to freshen up on my geometry before I do my next live stream. Or just have my notebook out. It's much easier when I don't have thousands of people watching. It's a lot less pressure. So someone has tweeted me. What is their name? Just a little shout out here. Rebecca Thorpe. Your Twitter name is RebecCat263.
What a cute name.
What a cute name, Rebecca. We're doing surds. We're doing radicals. X is an integer such that the square root of x times the square root of 18 divided by the square root of 3 is equal to 8 square root of 3. They want you to find the value of x. Well, as you know, our main rule is let's get all of the x's on one side, the variables on one side, and the numbers on the other side. Always a good shout. Also, if you have some of these square roots on the bottom, some of these surds, you don't like that. Your teacher doesn't like it. She's going to give you an F. You don't want an F. You want a 9 or whatever the GCSE thing is now. So multiply both sides by the square root of 3. Because if you multiply this by the square root of 3, the bottom cancels out. And then make sure you do it to both sides. As you know, you do something on one side, you have to do it to the other. So 8 square root of 3 times the square root of 3 is equal to 8 times, with this rule, 3, which is 24. I'll write out the step just in case you missed that. Square root of 3 times square root of 3 is just 3. So we have 24 equals square root of x times square root of 18. Square root of 18. What is so peculiar about that? You know there's some fun number in there that they're not going to give you a hard problem here. Square root of 18, let's just factor in. Let's see what we can get out of here. We know that the square root of 18 is equal to the square root of 1 times the square root of 18, which helps no one. We also know it's the square root of 2 times the square root of 9. Hold there. We don't have to do anymore. We found it. This is our boy. Square root of 9. 9 is the perfect square. So right now, we know that if we factor square root of 18 into these two, we can change it to square root of 9, which is just 3, times square root of 2. Ta-da! So that's square root of x.
Johnny, pop it on.
I'm alright, thank you. Times square root of 2 times 3 equals 24. Now, when Jack Bauer's finished doing this problem, he's going to be very proud of you, because you just realized there's a 3 on the left and a square root of 2 on the left. We need to bring them over. Divide 24 by 3. It's going to be 8. Divide it by square root of 2. 8 over square root of 2, that's not a 2, that's a 3, equals x. Like I said, you could stop here and say that's the correct answer, but a lot of teachers don't consider this perfect form. You want to get the square root out of the bottom. And how do you get something out of the bottom? Use your finger, multiply top and bottom by the bottom. And that's going to be x equals square root of 2 over square root of 2 times 8 over square root of 2. And as you know from this rule right here, square root of 2 times square root of 2 is just 2. You did it. So it's going to be 8 square root of 2 over 2. I'm going to write that real big just in case you can't see it. Ta-da! What's up?
I think I was watching you.
Oh, just watching.
Learning maths.
Learning some maths. Everyone seems to have issues with geometry and surds. So this is the problem if you want to screenshot it. I know it's a bit hard to see. I'll up my budget for the next one. Don't even help me. Do it on my own.
Because I can't find it. Like a
Let's see.
vegetarian korma.
Oh, I'd love to do some integration by parts. Trigonometry. Oh boy. Like I said, if you want to join in, tweet me using the hashtag Evan help my math. It sounds fun, right? That one came from Rebecca Thorne. Thank you, Rebecca. Ooh. Someone's given me one in Spanish. Sistemas según los valores del para, which I believe is just systems of
Did you find the
equations.
Hannah Sweets thing?
Did I find that? No, I haven't found the Hannah Sweets problem.
Somebody sent it to me.
Could you send me Hannah
Oh,
Sweets?
it's House Slytherin again. I'll send it to you.
There we go. Hannah Sweets, if you are unaware, is an iconic problem in the British testing system that everyone complained about last year. It is a probability problem, which means you're probably in love with it because it's very fun. Everyone loves probability. It's a useful one.
Oh,
No.
I hate fractions.
I mean, fractions aren't fun, but they're not evil. All right. Who likes Hannah? No one. Unless your name's Hannah, everyone loves you. Please, keep going. We're going to love it when you finish this test and get an A. Number 1. This is Hannah Sweet's problem, the infamous problem. If you're ready to get an A on this test, follow along as closely as you can.
I didn't know
The problem says there are N sweets in a bag. All right. N sweets. We don't freaking know. Just N. 6 of them are orange.
that. Yeah, I guess what I said.
All right. So I'm going to write down 6 of N are orange. And it also says the rest of the sweets are yellow. All right. The rest of the sweets, well, if we know if there's N in total, and 6 are going to be orange, and the rest are yellow,
Actually, pop it on.
then N minus 6 is yellow. I hope that makes sense. Right? So I'm just going to do that one more time. I know it might be slow for some of you, but for some, you need this. 6 of the N total are orange, so the rest would just be the rest. N the total minus 6. Good, capiche, we did it. All right. Next, Hannah takes a sweet at random from the bag. She eats the sweet. The fat oaf. So Hannah just took one. That's it. End of the problem. Hannah then takes at random another sweet from the bag. I'm glad this isn't a replacement problem because it'd be like, Hannah eats the sweet. She spits it back out, puts it back in. She didn't do that. She took one sweet from the bag and eats it. She then takes another random sweet from the bag and she eats that sweet. The probability that Hannah eats 2 orange sweets is 1 divided by 3. Finally, we have a number. When you're reading a word problem, they're really annoying. Just look for the numbers. This one says the probability. Also, just so you're aware, we're going to say O is orange and Y is yellow. The probability that Hannah eats 2 orange sweets is 1 over 3. I'm just going to put O2 so you understand what that means. So the probability that she pulled out 2 orange sweets is 1/3. Show, oh, and here's where it gets crazy. This is where people get really angry. Because then it just says, show that n squared minus n minus 90 equals 0. And most of you are like, how the flipperty what? This is meant to scare you. You know, don't even look at this. Don't look at this shit. You don't just, here we go, ready? You don't give a crap. At that point, that is basically giving you the answer, and it's supposed to scare you away from finding it, because it looks complicated. Instead of looking at that, I just want you to find out what is n. I want you to know what n is. You have all the information here on finding out what n is just from this, right here. Here's your ticket. If she pulls out 2 sweets at random, one after the other, and it's 1/3, you can solve what n is. How do we do this? Well, the probability of pulling 1 orange out, just 1 orange, is equal to what? Well, we know there are 6 of them, so it's going to be 6 over the total, n. Is that good? Is good? Let's just say she had 10 sweets, and 6 of them were orange. What's the probability she pulled an orange out? 6 out of 10, right? There's 10 chances to get a sweet, 6 of them are orange, 6 out of 10. I'm feeling like it's 6 out of... Okay, sorry. So we got 6 out of 10, except it's not 10, it's n. It's confusing you with the... because you don't know what it is. But the probability of pulling out an orange is 6 over n. Good. However, she pulls out 2 sweets, one at a time. What's the probability the second one... We're going to give that a base 1 and a base 2. What's the probability the second one is also orange? At this point, because it's not replacement, you know that the total of sweets is no longer n, it's actually n minus 1. All right, so how many orange ones are left? Well, there were 6. We've taken 1 out, so the probability of getting an orange one is now 5. Out of what? Well, there's 1 less than n, because we pulled 1 out, so it'd be 5 over n minus 1. We're really close to the answer here. We're very close. At this point, if you recall, it says the probability of doing this is equal to 1/3. So the probability of pulling out an orange and then pulling out another orange is 1/3. You know that in order to calculate that probability, you just have to multiply them. You multiply the probability, for instance, the probability of getting 2 heads in a row is 1/4, is 1 over 4. Because you're flipping it, the probability is 1 over 2 times the probability of it twice, 1 over 2. So the probability of getting orange is 6 over n. The probability of orange the second time is 5 over n minus 1. If we multiply these 2 numbers, we'll find the probability of getting them both. Exciting. So the probability of O, I'm going to put a big 2 O's, right, is equal to 6 over n times 5 over n minus 1. Here's the kick. We also know that's equal to 1/3. Hurrah! You know what's cool about that? We now have letters on this side and numbers on the other side. So now we can start solving. Now we can start figuring out what the frickety frick frack's going on. What I want to do at this point is, like, this is getting a bit ugly. Like, there's an n on this one, there's an n minus 1. What are you supposed to do? Well, ideally, you don't want any fractions because you hate fractions. And you know that in order to get rid of them, you multiply the top and bottom. However, a good strategy as well is to make these common denominator in a way. Or we could just multiply them, right? Let's just make this as simple as possible. Let's just multiply these 2 things. I'll start over here. 6 times 5 over n times n minus 1 is equal to 1/3. Does that make sense, Hannah? Hannah, you sweet stealing bitch. Okay. That is going to be 30 over n squared minus n. And that's equal to 1 over 3. Hope that's making sense. We're getting really close, as you can tell, to the actual answer that was given to us and saying, show that this is the thing. At this point, we have n's over here. We have numbers up here on the same side. Bad. What we want to do is go back. We want to take the letters, the n's, and bring them to the other side out of the denominator. So multiply both sides by n squared minus n, all right? Do it to both sides. What you're going to get is these canceling, and you're going to get 30 equals n squared minus n, yes, over 3. However, we yet again have a fraction, and you hate fractions. So is your teacher. Bring that 3 back over here, and you get 90 equals n squared minus n. Guess what, fam? Guess what? In order to solve this, we need to bring everything over to one side and get that 0 coming out. So that gives you, let's subtract 90 from both sides, and you get n squared minus n minus 90 equals 0. What the fuck? That's literally what A said. It said show that n squared minus n minus 90 equals 0. Done. You've solved the problem. You draw a little square and you color it in. The teacher will be like, wow, they know the cool square thing that math people like to do. QED, motherfucker. Like, that's it. If you want to actually solve it, I think part B may say find how many sweets were in the bag. In order to do that, you're going to have to do some factoring. 90 is a pretty big number. It might scare you. However, it's not that scary. Immediately, you look at 90. What 2 numbers do you think of? Boom. What do you think of, Connie? 90. What 2 numbers multiplied equal 90? Immediately. What 2 numbers can you multiply together to get 90? Easiest ones.
9 and 10.
9 and 10. First ones you can think of, because it's a 90. Come on. So if you just go with 9 and 10, n minus 10, n plus 9 equals 0. Let's just do the math there, make sure that's correct. N times n is n squared. Negative 10 times 9 is negative 90. And then here we have negative 10n plus 9n, negative n. We did it. There can't be a negative amount of sweets in this bag. So the answer cannot be negative 9. However, it can be 10. The answer is 10. There are 10 sweets. Remember when I said 6 out of 10? I wasn't messing around. That was it. So basically, if you're having issues with this part, this should be hopefully once you get to this is like the home stretch, the easy part that you should love, factoring. If you don't love factoring yet, you need to do more factoring problems because they get better. You should begin to see like different puzzles. You got like 90 is 5 times 20. My bad. 5 times 18 is 10 times 9. 2 times 45. 1 times 90. Once you put these all out in your head, you then want to find subtracting the factors, which ones will come to negative 1 or whatever this number is here, and then you can find it. Hope Hannah helped you today. I hope that was helpful. If it was, tell me. That was nice. I love you so much. Thank you, Marie. Appreciate that. Hope this has helped. Super chat me. Don't. Cool. So at this point, Hannah's problem is solved. If you want to do a screenshot, I'm going to let you do that now. If you're solving problems, this was on the GCSE last year, and there's going to be a similar one probably this year, and it will annoy you. Here you go. Ready? Ta-da! Hey. Cool. I'm now going to erase it. Who doesn't love a good probability problem? Supposedly you.
Probably them.
Probably you. Statistically speaking, no one. Thank you. Thank you, Connie, for the Hannah's sweet problem. It looks like Lucy has also tweeted me that. Oh, solve. Oh, yeah, part B was literally just solve it, which we just did. I mean, it felt bad not solving the whole thing. Do. Itching my nose.
You have to clarify that in case somebody thought you were picking your nose.
What, this? Yeah, I'm itching the outside of my nose, mate. You know, you gotta get an itchy nose. I don't... Gradient. Oh, gradient functions. Wow. Thank you again for the geometry. Oh, we got some algebra. Most of the algebra you guys are tweeting me is stuff that involves plotting things. I'm not going to be plotting anything, sadly. I'm going to be mostly doing ones that I can show without plotting. Plotting. Whoops, someone's making me turn my head. This is my 3rd time tweeting you this. Please help. Find the value of n. Oh my gods. Here's where logarithms come in. Something that I loathe. So I actually can't help you with logarithms. You're going to actually have to read the book for that. I'm really sorry. Logarithms are something that is sadly lost. It's been gone. If I read up on it for 5 minutes, I could then explain it. It'd come back. It's like another language, but I can't do that right now. I'm sorry. The cosine rule. I'd love to help you if you tweeted me a problem. Ooh, someone tweeting me some good stuff. We have summation problems. We've got work out the values of a, and again, sadly, logarithms. Help me with Spanish. No sé español. Ich bin sehr schlecht am Spanish. 5x squared plus 2x plus 1 will be the stream. What? That's not even a problem. Hey, here we go. Use the appropriate identity in each case. Find the values of 4 cosine 2 alpha equals sine squared alpha. I'm pretty sure you're going to have to use your, if you're taking, what course is this? Trigonometry or calculus, you're going to just have to use your, I don't know if they have this in the UK, cheat sheet. We were given a cheat sheet and then also our sheet of formulas.
Cheat sheet, not Chi-Chi from Dragon Ball Z.
No, not Chi-Chi from Dragon Ball Z, a cheat sheet. I was given this big yellow piece of paper that essentially you could bring with you to class and you'd get an A because it had all the formulas on it, such as what is sine of 2A, what is cosine 2A, what is the sine squared A, the formulas such as like sine squared A plus cosine squared A equals 1. You need to know those things. That's literally just memorization if you're not allowed to. So I can't really help you with memorization. Sorry. If I could, I would. Imaginary numbers, those are fun. Someone just said, Trig, are you triggered by math or you want help in trigonometry? A certain... Oh, someone's given me an emoji on this. I have a large container in my garden for collecting water. Yet again, I can't do geometry, I'm sorry. Someone's just tweeted me Hannah's problem 4 times. Just did Hannah's problem, my love. My love. I'm scrolling to the top of these tweets. Thank you very much for everyone tweeting me these. I'm hoping to help another 2 people before I have to go. I still have to do my German. What's this one? The volume of bleach. That's something you shouldn't be telling kids taking an exam. Prove. I'm not doing any proofs right now. I'm sorry. I tried to work this out but failed. Please help. Given that x is greater than 3, find the exact value of x such that the inverse equals f of x. Ooh. I'd have to have a refresher on that. I can't just do that by heart right now.
I'll get some refreshers.
What?
They're British sweets. They're really
Oh.
yummy.
Combinations and permutations. I'm good at permutations and combinations. Send me a problem, and I can help you with that. Okay. Help me find the exact value of tangent of 7 pi over 12. Using a property that I do not have on me. I can't do it, I'm sorry. If you people are like, help me. I mean, I would love to if I had your formula sheet. I do not have the formula sheet. So but basically, I can do algebra, I can do surds, I can do probability, because for some reason, I still have those memorized. Let's see what Sky has tweeted me. Divide a rectangular property between 2 sons. The conditions are the house belongs to both parties. Both property must have the same shape. Parts must be connected. This is a weird problem. How is that algebra? Please help me. I have my exam on Wednesday. Please help me. I have my... Ooh, a growth problem. Those are like statistics. When will he pick one? When will he do a math problem for the people? Mixture of bicycles, tricycles, and unicycles. There are 7 saddles, 13 wheels. What? Okay, he's tried to tweet me this. Kate has tried to tweet me a problem within 13 characters. I'm going to try and do this, given there's only 140 characters. There's a mixture of bicycles, tricycles, and unicycles. Bicycles, tricycles, and unicycles. There are 7 saddles, which are seats, I believe, in England. Do you refer to seats as saddles? Sure. So there are 7 seats, 13 wheels, and more B than T. There's more bicycles. So we also know that there's more bicycles than tricycles. How many unicycles are there? What a nice problem. Well, first of all, we know that bicycles have 2 wheels and 1 saddle. I'll keep this up here. We know that tricycles have 1 saddle, Is this a horse bike? 1 saddle and 3 wheels, and unicycles have 1 saddle and 1 wheel. So this seems like it's going to be a system of equations because at this point we know there are 7 saddles. So the number of bicycles plus the number of tricycles we'll do plus the number of unicycles has to equal 7 saddles. Should I put little S's there? Yes, I should. Oh, I don't have to. We're going to do that anyway. So in terms of seats, the number of these is going to equal 7. Luckily, I can erase this S because there's 1 on each of them. So we're going to represent this as the number of each one. Capiche? Capuche. With wheels, there are 13 wheels. So we know there's, where are we? 1 wheel per unicycle. So that's going to be U. We're going to put an A as a coefficient, however many there are. Wait a minute. We're going to just go with this. Plus however many bicycles there are, plus however many tricycles there are, has to equal 13. We know how many. We know how many wheels are on a unicycle. Just 1. So we can erase that. We know how many on a bicycle. We've written that down. 2. Also, we're not idiot. Okay. And also there's 3 on a tricycle. So at this point, here we go. It's a system of equations. We also know that B is greater than T. I think that'll come into play later. Easiest thing you can do here, is to, as you can see, U is the same on both. Let's just multiply this entire row, this entire equation by -1. That gives you negative U minus 2B minus 3T equals negative 13. Now, if you look at this and this, if you add these up, you're going to get, oh, we might want to do a double substitution here. I'm trying to see. Only because we have 2 systems of equations right now, but we have 3 variables. And that is not normally solvable unless I have a trick here. Mixture of bicycles, tricycles, unicycles. There's 7 saddles, 13 wheels, and more B than T. So we're going to actually have to use this at some point. Either way, let's go with this. If you add this system and this new system that we've just multiplied, you're going to get 0 minus B minus 2T equals 7 minus 13 is negative 6. Okay, this is actually doable. So what I'm actually going to do is multiply the whole thing by -1 because I don't like that there's negatives everywhere. And literally you can do that. Isn't that fun? So we have B plus 2T equals equals 6. What can they equal? Let's write that big over here. B plus 2T equals 6. And we know that B is greater than T. So the number of bikes plus the number of trikes times 2 has to equal 6. In terms of what we have as possibilities, if B cannot be 1, otherwise tricycles would be 0, and it would not equal 13 wheels. If B was, let's just say 3, let's just say it was 3, tricycles can be either 1 or 2. And if B was 3 and T was 2, it wouldn't work. If B was 3 and this was 1 or 0 or 2, this would still not equal 6. So what we can do instead, let's just say bicycles is 4. 4 plus 2 times what equals 6? 1 times 2. So what if we used 4 and 1? Then this equation is satisfied. That's great. However, there's another equation. You can't just do that, Evan. All right, let's plug into this one then. If this was 4 and this was 1, you'd have U plus 4 plus 1, which is 5, equals 7. That would mean there's 2 unicycles. All right, so if U is equal to 2, B is 4, and T equals 1, what about this equation? It has to solve every equation. If U was 2, it would be 2 plus 8 plus 3. That's 13. You solved the equation. You did it. You solved the group. Congratulations, Kate Cat. We did it. We did it. Thank you, Kate Cat X. Kate underscore Cat X. You did it. Thank you very much. That is the answer. So when it says, how many you say, nothing was up with you. It's 2. Congratulations. I'm hoping you had a good time here. We're gonna do a couple more. I'm just trying to slow down the chat here. A lot of people want to do correlation coefficients. Those are fun. Oh, and by fun I mean not. That uses statistics software such as SPSS or R, correct? Oh man, I had to delete. Dein Deutsch hört sich schon echt gut an. Grüße aus Hamburg, Deutschland. Thanks. But this is the math chat. I'm so bored. I'm answering all the questions you want on Twitter. Well, thanks. Please help people. Someone just said T is 1, B is 4, U is 3. Yeah, boy. That's what it... Wait. U is 3? Really? Have I messed something up? 2? You're saying it's 3? If I did 3 plus... No, that can't be correct. That's not correct at all because those add up to 8 and we have 7 saddles. So, no, this is the solution. This boy. T is 2. I mean, I'm sorry, U is 2. Anyway, y equals mx plus b. Thank you for doing what do you want, the equation for slope? Can you verify? I just did. You plug in your solution here to both the systems of equation that were given, plus the b is greater than t. You know that 4 is greater than 2, so that solves that, and it also solves all of them. You need to do long multiplication. Tweet me a long multiplication problem. Those are pretty simple. Much easier to do than geometry. Thank you very much. If you hadn't screenshotted that, go back and rewind it a bit. Sorry about that. Hopefully all the CERD people are really happy. I'm just glad I did that. With that formula, 7 pi over 12 equals 7 pi over 6 over 2. Reversed percent. Well, let's see. Someone's got a really bad lighting going on right now. Okay, here's a probability one. I just itched myself really hard. So a game uses an unbiased die. This is something that I believe is in chapter 13 of the GCSE practice book. If you're doing GCSE, I looked at someone's at a meetup I did on Saturday. So this is, I believe, on GCSEs. A game uses an unbiased die with faces numbered 1 to 6. So literally he's just using a freaking die, a dice, whatever. The die is thrown once, and it made him want to die. Hey. If it shows 4 or 5 or 6, then this number is the final score. If it shows 1 or 2 or 3, then the die is thrown again, and the final score is the sum of the numbers shown on the 2 throws. All right, so basically, if x is equal to, let's just say 4, 5, or 6, then y is equal to x. Pretty good, right? Let's just do x1. However, if x is equal to 1, 2, or 3, then y is equal to x1 plus x2. Evan, what does that mean? I'm just trying to make it into numbers to make sense for myself. Basically, you're going to throw it twice. So let's just say you throw a 1, you get to roll again. And if you roll another 1, your score is a 2. However, if you throw a 1 and then a 6, your score is a 7. So even though like the highest score you could get at this is a 9, a 3 plus a 6. Cool. The question says, find the probability that the final score is 4. Here's a cheat hack, right? If you're taking this test and you want to make sure you 100% get the question right and you have a little bit of extra time, write out all the sample set. Write out every possibility. So let's just do this right now. This will save you so much time. This is how you ace your exams. If you're doing probability. Here's your first throw. 1, 2, 3, 4, 5, 6. Now, if you throw a 1, you get to roll again. If you throw a 2, you get to roll again. If you throw a 3, you get to roll again. However, if you do these, you don't. So we're actually going to cross that out. Those are 3 independent ones. So you throw it once, then you get to do it again. At this point, you can do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Not the most conventional way of doing this graphically, but it is to show you how many possibilities there are. If you throw a 1, you then get to roll it again, and you can have a 1-1. Or you can have a 1-2, or a 1-3, or a 1-4. Ad nauseum. You can also do 2-1, 2-2, 2-3, 3-1, 3-2, all the way here. How many are there? There's 3 of these and 6 of these, so there's 18 possibilities for the first 3. There's also 3 possibilities at the bottom. So there are 21 different possible scores you can get. Not different scores. There are 21 different different things you can have in your sample set. Sorry if I'm not using the correct term. Things. Obviously, like 1 plus 2 is the same as 2 plus 1, so it's the same value, but there's 21 different occurrences that you're going to have here. The question says, find the probability that the final score is 4. All right, so if we have the total here, you know the probability that it's 4 is just the number of events where it's 4 divided by the total. We already have the total because we counted it out. We took our time. Sweet. How many of these add up to 4? This one right here, 4. We also have 1 plus 3, we have 2 plus 2, and we have 3 plus 1. So right there we have 4 possible answers where it's 4. And we have 21 total. So the answer to part 1 is 4 over 21. Boom, you just got 3 points. This question is worth 7, so we literally are 3/7 the way there. We're almost halfway the points already. The next one says is only worth 1 point, so it's a little shit, but given that the die is thrown only once, find the probability that the final score is 4. Why is this worth 1 point? Because it's a very, very simple problem. It says it's thrown once. What's the probability you get a 4? All right? It's thrown once. Here we go. There's only 1 4. It's 1 out of 6. You have a 1 in a 6 chance. There's 6 different options. There's only 1 4. So part B, part 2, is 1 over 6. Cool. You've now got 4 points. You have 3 left to go. We're going to get you that A, that 9 in the GCSEs. Given that the die is thrown twice, find the probability that the final score is 4. Okay, I had to read that twice because I was like, isn't that the first part? No, it's trying to trick you. Part 1 said, what's the probability the final score is 4? What we did was, we found all the 4 possibilities. Now part 3 is a conditional probability. You don't have to worry about any formulas though. Luckily, this can be done easily since you did my method here. You wrote it all out. Hopefully doing this at home. Given that the dice is thrown twice, so that's the condition. The condition is you have to go into x2. What does that mean? It means that you have to have an x. The first throw has to be less than 4. It has to be 3, 2, or 1. So given that you're throwing it twice, what's the probability that it's 4? Well, there's 3 of these. We know it has to be in here. Don't add in these. At this point, the total is no longer 21. We're only going with the 18 right here. There's 18 possibilities because it says given that it's thrown twice. All right, so now we're just looking at this. How many are 4? 1, 2, 3 out of 18. The answer is 3 out of 18. Can someone do the math? What's that? Is it 1 over 6? Yeah, it is. The answer is 1 over 6, same as the other one. Of course, you have to show your work for it. So for this one that I've literally just shown, I'd have to write that. Or if for some reason you have the conditional probability theory memorized, the probability of A given B equals the probability of A and B over the probability of A and probability B. So if you have that formula memorized, good for you. I did for some reason. I like probability problems, so I still have that in my head. So the probability of A, which in this case is the probability the final score is 4, given that it's thrown twice, means you need to find what's the probability the score is 4. Oh, you know that. We did that for the first problem. So the probability that it's 4 which is probability of A, is equal to 4 over 21. Cool. What's the probability of B? Because we need to find that for this as well. That is given that it's thrown twice. So what's the probability that the die is thrown 2 times? It looks like that's just 1 over 2, isn't it? Because it's basically 3 chances versus 3 chances. So the probability that it's thrown twice is just 1/2. What's the probability that it's thrown twice and it's 4? Right? That's the true question. Because at this point, we have to do A and B. So the probability that it is 4 and it is less than it's thrown twice. And so in order to do that, I'm trying to make sure I've done this correctly. It should be 3. They're yelling over there. Is it 1/3? The probability of that happening is yes. Oh my gosh. Oh my gosh. My formula worked. Okay, so if you are using the formula method and not the, as you can see, if you don't have this memorized, write it out. Much easier. If you do have it memorized, probability of A and B is 1, 2, 3 over 18. So it's 1/3. Whoa, I've done the math. Very weird here. What have I done? I've done something very wrong. I know the answer is 1/6, but this is not 1/3. Stick with the table. My laptop is very soon to die. I need to charge it. Oh, I need to charge. Okay, I've done something wrong with my formula because this needs to come out to, if this is 1/2, then I'm doing something a bit weird because 3 over 18 should be 1 over 6, and if it's 1 over 6, then it'd be 1/3. I'm not going to work with the formula. Something weird. Someone could probably very easily see what's going on here. But I'm not going to spend more time on the formula because you already got the right answer. Cool. Pick your poison. Pick the poison that makes more sense to you. I hope that made sense to you. It starts my brain. Just turned in. Hello. Hello! Wish I came at the beginning. Oh, you did AP Stats. I would have helped you with that. In terms of... Is my laptop not charging? Oh my god. I'm going to die. There we go. Now we're charging. All right, you guys. I'm gonna be doing one more question. I hope that it helps you. Thank you very much for thank you to Harry Selden and Cardiffies for super chatting and donating. Cardiffies just tipped me £3.14, which is pie. Thank you for the pie, Cardiffies. I hope you get an A. I hope the gods bless you because you've blessed my super chat. Interesting. So I have the chat over there and then I have the slow chat. If you haven't, next time I do this, probably a good idea for isolated problems down there. I just noticed that that's down there. My bad. Completing the square. Yo, mate, that's the last one. I've got a lot of people texting me completing the square problems. I'm going to hook you up, fam. If you don't know, probably the best animator YouTuber out there, whose name is The Odd Ones Out. If you don't watch him, shame on you. There's 1,000 of you watching. Just go look at The Odd Ones Out. He's a very funny guy. He also enjoys math. And we worked together on a math problem once that some Twitter user DM'd us. So I'm going to now do it correctly because we were messaging each other when I was at Playlist Live. I was sitting by the pool on my cell phone trying to relax and then realizing I was losing my cool because this guy must have thought I wasn't good at math because I was too busy trying to relax and not doing the problem and I had it on my phone. Anyway, long story short, we're going to give you right now, all you lovely people for the live stream, completing the square problems. If you have any issues with completing the square, such as my person, what's your name? Haid Jobs needs completing the square problem. I've seen a lot of people, and Anna, here we go. This is for you. We're going to complete the square right now. We're going to do 4 problems. Oh my god, Evan, that's a lot. I know, but I care about you a lot, right? Care about you a whole lot. Here we go. Are you ready? Question number 1. It says, express in completed square form. We have take this off. X squared plus 7x plus 9. Now, I want you to do this in completed square form. How the frickety frick frack are you going to complete the square? I don't freaking know. Oh, wait, I do. You know, when you're completing the square, if it is, let's just say, x plus a squared. You know that if it's squared, which we're doing, it's going to look like this. And you know that if you multiply these out, it's going to be x squared plus 2a plus a squared. So, given that formula, if you want to ever complete the square, you want to look at the middle number. Whatever the coefficient is in front of the x that's not like multiplied by itself, just this one, that one, if you divide it by 2 and square it, will be the number that it's supposed to be at the end. I'm going to try and say that again a bit more slowly, so hopefully you can comprehend it. I should have closed it. I'm going to close the door because it might be getting a bit loud. Okay. Not yet. Almost done. All right, I'm back. Anyway, so if ever you're trying to complete the square, I'm going to try and do this so once I do these 4 problems, you'll totally get them. You won't need help anymore. You'll be good. I know it's annoying when you're seeing me do it with an A, so I'm going to do it with a 2. I feel like that might help you a bit more. I know people get scared of letters. They're a bit confusing. So x plus 2 is x squared plus 2 times 2x plus 4, which is 2 squared. Whew. So when you want to complete the square, and you're given this right here, you know this, right, 7x, you know that if you divide 7x, just as this one is, by 2, you'll find what the thing is that you square to get this. Just trust me here. I wish I could make this make sense more. I'm just going to do the problem. I feel like that might help. We'll do 4 of them. In this one, just ignore the 9. Just push him to the side. He's actually feeling a bit alone because he's just a number. So I'm going to push him over. What we have here is 7. What's 7 divided by 2? I don't know. That's not a fun number. It's 3.5, but let's just leave it as 7 over 2. What we know about 7 over 2 is that it's what we're supposed to be squaring to complete the square. That's literally it. If we want to make a complete square here, we're going to have to do this. Evan, you can't just add numbers to an equation. You're right, I can't. That's not allowed. I just added 7 over 2 squared. That's not possible. What do I need to do? I need to subtract it as well. Remember that lonely 9? Let's mess them up. Minus 7 over 2 squared. What do we got here, my fan? What we got here? What we got is x plus 7 over 2 squared. You want to check my math? You don't have to because it's completing the square. I mean, but you should also check my math because I mess up sometimes. X times x is x squared. X times 7 over 2 times 2. X times 7 over 2 times 2 is 7x. And 7 over 2 squared is 7 over 2 squared. I don't feel like calculating out 49 over 4. That's not a fun math equation, so we're just going to leave it like that. However, it's not finished because we have plus 9 minus 49 over 4. Now, if you want to get the points, you probably should be doing this right here. What's 9 minus 49 over 4? Well, 9 is actually 36 over 4. If you don't know how to do that, all I had to do there was find a common denominator. So I said, what's 9 in fours, in quarters? 9 times 4 is 36. So 36 over 4 is the quarter term for 9. So 36 over 4 minus 49 over 4 is equal to negative 13 over 4. So the correct completing the square answer for this is right here. I'm going to let you screenshot it if you're having issues with completing the square. X plus 7 over 2 squared minus 13 over 4. Boom! We did it. We did it, fam. Now, this one goes out to my girl Emmy and her uke, legally Emmy, on Twitter, who tweeted at me and the odd ones out together, who sprung our beautiful math friendship, and we worked together on this, me and my boy. So I'm now going to do 3 more of these. So if you're still having issues with completing the square, this will end all your issues. You'll come into class tomorrow, and your teacher will see a new man / woman / however you identify, and she'll be proud of you, right? Just like I am right now. Here we go. We're gonna do another one. X squared minus 7x minus 3. How can we complete the square? Like I said, if it says complete the square, if you see a number hanging out by himself, you tell him to piss off. He's being a little lonely. We're going to just bring him all the way over here. Minus 3. Nobody likes him. He's hanging out alone. If you want to hang out alone, I like you. It's fine. 7 over x. What do we want to do to find how we're going to complete the square? First of all, something to note, we have a negative now. It's negative 7. That means when you're writing the answer and completing the square, it's going to be x minus something. It's not x plus anymore. How do you find out what it is in the middle? Divided by 2, remember? Just take the middle one, divide it by 2. Why? Because when you're foiling, when you're making this equation, which is definitely not boobs, that wasn't what I was drawing. When you're writing out the binomials, you know that it's just, when you're making a square, it just doubles the exponent, the x with the 1 exponent. You know what I'm saying? Like this one is just x squared. This one is just doubled. So if you do 7 over 2, again, x minus 7 over 2, x minus 7 over 2. It's basically the same problem as last one, except this one is negative 7 over 2. However, like you know, you cannot just subtract, 7 over, you can't just add a number to an equation. You can't just do that. Evan, why have you just made it positive though? I thought it was negative. What's wrong? If you square a negative number, it makes it a positive. And so when we add, what you should know is if you're completing the square problems, the number that's hanging out alone at the end of the day that makes this binomial cannot be negative. You cannot have a negative because when you square it, it's going to be positive. So we added half of this squared. 7 over 2 squared, done. Hoping that makes sense. We already know that from the last problem, it's 49 over 4. But you need to subtract it because you can't just add things to an equation. That's not how math works. Can't do that. So we've added it. So now we're going to do minus 49 over 4. Ta-da! Simple. Simples. What we got here is x minus 7 over 2 squared minus 3 minus 49 over 4. I want you to find a common denominator between 3 and 4. I'm sorry, it's 3 over 1. So multiply the top and bottom by 4. You get minus 12 fourths minus 49 fourths. Evan, I hate adding negatives and fractions. Don't forget the zap-zap method. Zippity-zappity. Zappa-zappa. What we have now is negative 12 fourths plus negative 49 fourths. That's easy. You now know the numbers get bigger. So 12 plus 49 is 61. So it's negative 61 fourths. The answer is x minus 7 over 2 squared. That's the squared. Minus 61 fourths. You did it. You've done it. You've solved the problem. Hope everyone's enjoying this. Let me just, oh my god, perfect time. I'm getting ready for math finals. Cool. Who else watches? Hopefully this is helping. I've made a couple math jokes. What am I watching? You're watching a math live stream. That's what you're watching. You're watching learning happening. We have two more problems. I'm going to do one more in this same sense, and then one that's a bit different and should be easier for you to solve. So make sure, if you're doing these at home, write them down and try and solve them later. X squared minus 9x minus 1. Right off the bat, make the 1 go a little bit further away. He's hanging out over there. This divided by 2 squared. So what's that divided by 2? 9 halves. So plus 9 halves squared. And don't forget, you have to minus 9 halves squared from both sides. You cannot just add. So you're adding plus 9 halves squared. You're subtracting 9 halves squared. And that gives you, and as you can see, we have a negative here. I'm speeding up on this one because it's the same concept. X minus 9/2 squared is this. You've got the square completed. All we have to do is the math here. -1 minus 81. Oh. No, that's yeah, we're subtracting, I'm sorry. Minus 9/2 squared. 9/2 squared is 81 over 4. This, -1, is actually -4 over 4. So, zap zap, the answer is x minus 9/2 squared minus 85 over 4. You did it. You did it. It's getting much faster, hopefully. The next one, if I just change this to a 3, you should immediately see it's going to be minus 3/2 squared plus 3/2 squared minus 3/2 squared. Take that number divided by 2, square it, square it. Boom, boom. You can do it. One more problem. Crack the nuts. We've done surds, we've done rationals, we've done algebra, we've done probability, and lastly, we've completed squares. Whew, here we go. Solve by completing the squares, what this one says. X squared minus 8x minus 4, this is my last problem,
Okay.
equals 0. My last problem for you. We just need to complete that square. Don't forget, we're going to move that -4 as far away as possible because he's lonely. Divide this number by 2. 8 over 2. And, let me see, plus, I'm going to do 8 over 2 squared. Don't forget, you can't just do that. You have to minus it as well. Minus 8 over 2 squared equals 0. This is the same type of problem we just did, except with an extra step of solving it. So now that we know it's 8 over 2, which 8 divided by 2 is 4, we have x, and it's a minus 4 squared. -4 minus 4. Evan, I get it. I'm going to stop you there. Zap, zap. -4 plus -4 is -8. So we have x minus 4 squared minus 8 equals 0. Whew. Solve the system of equations. Here we go. X minus 4 squared equals 8. Take the square root of both sides. This is where it gets both into surds territory now. X minus 4 equals the square root of 8. What's the square root of 8? You know the 8 is 4 times 2. So that is equal to the square root of 4 times the square root of 2. Square root of 4, that's a perfect square, man. Square root of 4 is just 2. So we have x minus 4 equals 2 square root of 2. We still have a number on the same side as x. That's not cool. Segregation is x equals 2 square root of 2 plus 4. That is your solution. That is your answer. Any teacher in the right mind will give you top marks for showing all your work. You draw, don't forget, after you're done, you do this little square and color it in. And they'll be like, wow, what a smart person I have in my class. I can't wait to give her a 9. You did it. Thank you very much for showing up to the live stream. I hope that you get all A's and that your completing the square goes so well. Hope this helped you. Hope you've had a great day. Thank you so much for showing up. Good luck on your tests. I might be doing more live streams throughout the week. So yeah, I'll be doing them here. Thank you. I'll see you next time. I'll tweet out when I'm doing a live stream, so follow me on Twitter, @EvanEdinger.